How's it going? Today we're going to be updating our character controller to be able to take on slopes. So we've been able to do, obviously, walking and running on sloped like hills. But if, let's say, for example, the slope is a little bit too steep, we need to make sure that the character falls down the slope. And that's what we're going to be dealing with today. So, alright, so let's jump right in. First thing I'm going to do is I'm going to move the player over. So let's just put him right up here. And I'm holding control in order to lock him, in order to move him in increments pertaining to, I guess, quarters of a meter. And then I'm actually going to rotate him as well. Let's open Pro Builder, and I'm just going to take this, bring it way up and way over. This is kind of just going to be our our slope. So we want to fall down this. So let's do that. So right now, if we just kind of have a look at what happens when we hit this little slope here, it doesn't work the way we need it to. So first of all, you can actually run down it. You can't really see it. Maybe I'll do this way. But you can actually run down it, which is not supposed to happen. You can't run up it, but you can jump up it, which is also not supposed to happen. You're supposed to basically slide down that. So let's go into the player controller and make a few changes. So first off, let's have a look at where we're dealing with our slopes. So inside ground direction. So basically, just to sum everything up, this is inside this if statement is where we're solving the problem of taking slopes, both in terms of smoothness and in terms of the speed. And we want to limit this to only happen if slope angle is less than or equal to controller dot slope limit. None of this is going to happen if this isn't happening. And there's actually a lot of stuff that we need to make sure doesn't happen. So the next thing is also if the controller basically is grounded and if the slope angle is less than controller dot slope limit, then we want to be able to do stuff. But if the controller is not grounded, or the slope angle is greater than controller dot slope limit, we don't want to do stuff. And actually, I'm going to add the check to see if it's smaller than controller dot slope limit to jumping. So to make sure that if it is less than or equal to controller dot slope limit, you can jump. So now, just based on those couple changes, let's have a look at what's different. So the answer is we get stuck. We can't do anything. We just get stuck. So how are we going to solve this problem? Well, basically, the way we solved it before was with a ground direction object, and it basically followed the direction. So what we need to do is we need to duplicate this object and call it fall direction. And since we're pretty much done with ground direction, I'm actually just going to turn off the axes, and maybe I'll set up a really quick set of bools here. We'll just go under maybe above references. We'll just call this debug. Go public bool ground normal and fall normal. And we will, underneath get inputs, we'll just go void debug. And then inside debug, I'm basically just going to go ground direction dot get child o. Since there's only child, that's all that we need. And then dot game object dot active set active, and I'm going to set this to show ground normal. And then we don't actually have the other object, so I'm just going to quickly create a fall direction and do the exact same thing. I'm just going to copy this. We're going to go fall direction. This is going to be show fall normal. And then I'm going to grab player and drop fall direction in here. Check fall normal. Let's just play this so that we can see basically that it isn't working because we're not actually running the method. So let's just throw this into updates right here. Actually, no, let's throw this into ground direction right at the end. Cool. We can have both. Cool. Alright, so now that that's done, we actually need to set the fall angle. So in order to do that, we basically need to set the direction first. So let's go fall direction dot rotation. Nope, not root. Rotation. And we're going to set it equal to transform dot rotation. And then in here, we're going to go else if slope angle is greater than controller dot slope limit. So basically, in order to handle this problem, I did a little bit of searching online to see how I could just get the sort of downward direction of a normal. And this is what the best suggestion was. So we're going to create a new vector 3. We're going to call it cross, or no, ground cross. I'm going to set it equal to vector 3 dot cross ground hit dot normal and vector 3 dot up. Then we're going to go ground direction dot rotation. Nope, not ground direction. Fall direction dot rotation is equal to quaternion dot from to rotation. The first one is transform up, and the second one is vector 3 dot cross times, sorry, vector 3 dot cross, and then what you have is ground cross, and then the second one is ground hit dot normal. So to be honest, I can't really explain to you why this works. All I know is that I found it and it works. I found it online. And there it is. There's our fall direction lining up with the downwards direction of the normal. So now we actually need to apply this to our fall direction. So I'm going to come into here and apply fall direction dot up. So we're always going to fall on the upwards direction of velocity y. In addition to that, actually, one of the things that I noticed is that this doesn't actually work because this needs to be the case for this to work. Also, this doesn't actually allow for the smoothest of sort of the smoothest falling. So we're pretty much going to have to add something completely new. And so it's going to be else if controller dot is grounded and slope angle is greater than controller.slope limit. And then velocity y is going to be equal to mathf.lerp. Velocity y will be the first one. The second one will be terminal velocity. And this will be set to 0.25 f. And now we should be sliding down hills like a pro. There it is. Perfect. Alright, so there is one final thing that we need to make sure is happening when we slide down our hills. So just like with the slopes, once you take the angle of this and apply terminal velocity to it, you're actually slowing down the vertical direction because you're basically applying a speed to a normalized direction. So you're falling downwards much slower. So in order to solve this, we basically need to do the same thing that we did up here with the trigonometry. So let's create a new multiplier underneath. I'm just going to create it at the bottom of velocity. I'm going to call this one fall mult. I'm going to take that and I'm actually going to put it into our lerp over here and multiply terminal velocity by it. Or actually, no, I'm just gonna go in and multiply velocity y by it. And then in here I'm going to do, well, first we need to set this fall mult equal to 1 so that it always resets to 1 when it's not on a slope. And then in here what I'm going to do is I'm going to go fall mult is equal to 1 over mathf.cosine. And this time I'm going to make it, put it inside brackets. It's going to be 90 minus slope angle. And the reason why we're doing that is because we want to measure the angle from the up vector rather than from the sort of ground vector, if that makes any sense. Times mathf dot deg to red. And there it is. So let's just reveal fall mult real quick. Alright, so fall mult's not doing anything. And then as you can see, it's 1.722. And I basically just want to make sure that as this y vector approaches the main y vector, it kind of just gets closer and closer to 1. We're basically applying a larger multiplier when the angle of the slope is much closer to the slope limit of our character controller. And then when we hit the ground, it resets. Oh, I screwed that up. Let's just try that again. So the multiplier changes, and then we hit the ground and it resets. Alright, let me just double check this so that I can see how it's working. Alright, I'm just going to inch super close and jump. Whoa! Alright, that wasn't expected, and I think I know what was going on there. The reason why this is the case is because this number is so high. And you might be thinking, well, it's half, it's like 0.5, so what do you mean by high? Basically, 1 is 1 meter, and this is like half a meter. So that's like 1.5 feet, maybe a little bit more or less, just roughly around there. And if you're thinking that I could just take this number and bring it down, well, that's not actually the case. So what I actually have to do is I think I have to measure the distance from groundray.origin. So I'm going to create a new float. Let's call this ground distance. And we're going to set this equal to vector3 dot distance. We're going to use ground array dot origin to hit, no, what is it? Ground hit dot point. And then let's say that the number needs to be like, we'll do 10. So if, 10 centimeters. So if ground distance is less than or equal to 0.1 f, then we're going to do all this. And that should help us out. Alright, let's try it out. Just gonna test it again, see if I... Yeah, alright, so from what I can tell, it's basically solved our problem. And yeah, that should be it. So there is actually one final thing, and this is just while recording this. It's not a problem that I have essentially run into, but before, when I was trying to figure this out, one of the things that ended up happening was as I approached that from like a very sort of sharp angle, like the, you know, you're trying not to fall really hard, you're really trying not to fall, and as you hit that angle, what the controller would end up doing was it would end up getting stuck on the corner here. But I'm just not having that happen to me. So if you do run into that, please let me know, because I do have a solution for it. But if it's not a problem, maybe that'll just be like an addendum. Maybe that'll just be like a bug fix sort of thing. Alright, so that pretty much covers it for just walking and running and that kind of thing and jumping. Basic character controller stuff. I think the next big thing I'm going to do, like the next big set of videos, like continuous videos, are going to be about the camera controller in World of Warcraft. And that's a pretty complicated thing, but I think before that I might actually have to do a couple things, make a couple changes. So probably the next video is going to be kind of like a filler. I don't want to say filler because it makes it sound like it's a useless video, but it's not. I'm basically going to be making some changes and adding some things that are very important for the camera. Anyways, that's pretty much it. I mean, this video is late per my standards, so probably going to try and get the next video out as soon as possible. And I don't know. We'll see. We'll see what happens with this series. I'm kind of liking it. I'm liking seeing all the comments and seeing, you know, being at work and seeing the little subscriber notification on my phone is pretty cool. So, yeah, I really appreciate all that. And I guess I'll see you guys next time. Thanks for watching.
Super trooper, super trooper, super trooper, and he sells soup.